Welcome back to the Deep Dive, listeners. Today we're diving into a fascinating topic, one that I think you'll find has some really interesting implications for understanding, well, progress and efficiency, I guess you could say, in a whole bunch of different areas. We're talking about Wright's Law.
Wright's Law. Okay.
And to guide us through this, we have joining us a true expert on this subject. Welcome to the show.
Thanks for having me. I'm excited to dive into this. It can be a little bit technical, but it's also really intuitive when you start thinking about it. And we'll be using, for this deep dive, primarily the Wikipedia entries on experience curve effects and learning curve. Those give us a really good foundation for understanding this whole concept.
Okay, great. So for our listeners who might not be familiar, what exactly is Wright's Law? I mean, when I first heard the term, I have to admit, it sounded a bit intimidating, like something out of an economics textbook.
Yeah, it definitely has that kind of, a technical ring to it. But at its core, it's actually a pretty straightforward idea. It's all about the relationship between how much of something we produce and how much it costs to produce each unit.
Okay, so the more we make, the cheaper it gets. Is that basically it?
You got it. That's the essence of it. And it's not just some random observation. It's been observed and studied across a huge range of industries and products, from airplanes to microchips, from cars to, well, you name it.
So there's actually some data to back this up. It's not just a gut feeling.
Oh, absolutely. And it goes back a surprisingly long way. Before we even get to Wright's Law itself, it's worth touching on some earlier work that laid the groundwork for this whole idea. Back in the late 1800s, a German psychologist named Hermann Ebbinghaus was studying memory, and he found something pretty remarkable.
Oh, this is fascinating. Tell me more.
So Ebbinghaus was doing these experiments where he'd try to memorize lists of nonsense syllables, just random combinations of letters. And what he discovered was that the more he practiced, the easier it became to memorize those lists. Not only did it take him less time, but he also made fewer mistakes.
So he was literally learning as he went along, and that learning showed up as a measurable improvement in his performance.
Precisely. And this wasn't just about rote memorization. It was about his brain becoming more efficient at processing and retaining information through repeated exposure and practice. His work really highlighted that fundamental link between experience and improved performance, even in cognitive tasks like memory.
So that's the seed of the idea. But how did we get from memorizing nonsense syllables to, like you said, airplanes and microchips? How did this idea of learning through experience make its way into the world of manufacturing and industry?
Well, that's where Theodore Paul Wright comes in. He was an engineer working at Curtis Wright, an aircraft manufacturer, back in the 1930s. And he observed something pretty striking in their production data. He noticed that every time the total number of aircraft they had ever produced doubled, the amount of labor required to build a new aircraft fell by about 20%.
Wow, 20%, that's a pretty significant drop. So just by virtue of having built more planes, they were getting much faster and more efficient at building them. And that's where the term Wright's Law comes from.
Exactly. That specific 20% decrease observed in the aircraft industry became known as Wright's Law. It was really one of the earliest quantifications of this learning curve effect, which describes how costs tend to decline as cumulative production increases.
So this learning curve, is that basically the same idea, just applied more broadly to different industries and products? I mean, is Wright's Law essentially an early example of a learning curve in action?
Yeah, that's a good way to think about it. The learning curve is a more general model that captures this phenomenon of cost reduction with increased production. And while that initial 20% figure was specific to aircraft manufacturing at that time, studies across a wide range of industries have shown similar patterns. I mean, you see it in car manufacturing, shipbuilding, electronics, software development, you name it. The exact percentage might vary. Some industries might see just a few percent reduction per doubling, while others might see closer to 30%. But the trend is remarkably consistent.
So it seems like this learning curve is kind of a universal principle, at least in a lot of manufacturing contexts. But what exactly is it about producing more that leads to these efficiency gains? I mean, what are the underlying mechanisms driving this effect?
Right, it's not just magic. There are some very real factors at play. And the primary driver, as we hinted at with Ebbinghaus, is learning, but not just in the individual sense. It's learning that happens at multiple levels. At the individual worker level, at the team level, and even at the organizational level.
Okay, so break that down for us. How does learning actually translate into lower costs and greater efficiency?
Well, at the individual level, as workers repeatedly perform the same tasks, they naturally become more skilled and efficient. Think about it. The first time you try to assemble something, it probably takes you a while, and you might make a few mistakes along the way. But as you do it over and over again, you develop muscle memory, you figure out the best way to position things, you anticipate the next step, and you just naturally become faster and more accurate.
That makes perfect sense. It's like any skill, really. The more you practice, the better you get. But how does that individual learning scale up to the level of an entire factory or a whole company?
That's where things like standardization, specialization, and methods improvements come in. As companies gain more experience producing something, they often realize that certain parts or processes can be standardized, which reduces variability and makes things more efficient. They can also specialize their workforce, allowing individuals to focus on specific tasks that they become highly skilled at, rather than trying to be a jack of all trades.
So it's about optimizing the entire production system, breaking things down into smaller, more manageable chunks, and finding the most efficient way to do each one.
Exactly. And it's not a one-time thing. Companies are constantly looking for ways to improve their methods, whether it's through process reengineering, implementing new technologies, or simply finding better ways to organize their work. And as they implement these improvements, they learn from what works and what doesn't, and that learning feeds back into further improvements.
It sounds like a continuous cycle of improvement driven by this accumulating experience. And you mentioned technology. What role does technological innovation play in all of this?
Oh, it's huge. I mean, think about the impact of automation, robotics, and advanced manufacturing techniques. These technologies can dramatically increase productivity and efficiency, often allowing us to do things that were previously impossible or prohibitively expensive. But technology itself is also subject to this learning curve effect.
How so? I mean, isn't technology supposed to be about like breakthroughs and sudden leaps forward?
It is. But even with breakthroughs, there's still a process of learning how to best implement and utilize those new technologies. Think about, say, the development of 3D printing. The initial hype was all about how it would revolutionize manufacturing, and in many ways it has. But it also took time for companies to figure out the best materials to use, the optimal printing parameters, how to design for 3D printing, and so on.
So even with a radical new technology, there's still this learning curve as we figure out how to use it effectively and integrate it into existing production processes. It's not an instant game changer.
Right, it's an evolution. And that evolution often involves a lot of trial and error, experimentation, and knowledge sharing within the industry. And as we gain more experience with a particular technology, we often find ways to improve its performance, reduce its costs, and expand its applications.
Okay, so we've got this idea of learning happening at multiple levels. Individual workers getting better at their tasks, companies optimizing their processes and adopting new technologies. And all of this contributes to this downward trend in costs as we produce more. But is there like a mathematical way to express this relationship, to quantify this learning curve effect?
There is. And it's actually pretty elegant, though it might seem a bit intimidating at first glance. It all starts with what we call the progress ratio, which is usually represented by the letter B. Think of it as the percentage of the cost that remains after you double production. So B is 0.8. That means every time you double the total quantity you've ever produced, the cost to make the next unit is only 80% of what it was before the doubling.
Okay, I'm following so far. So a lower B means a steeper learning curve, faster cost reductions.
Exactly. And the flip side of that is the learning rate, which is just 1 minus the progress ratio. It tells you the proportion by which the unit cost decreases with each doubling of cumulative production. So if your progress ratio is 0.8, meaning your costs are 80% of what they were before, then your learning rate is 20%, meaning you're seeing a 20% cost reduction with each doubling.
Okay, that makes sense. But how do we actually use this to calculate costs? I mean, is there a formula for this?
There is, and it's a power function. It looks like this. Cx equals C1 times x raised to the power of log base 2 b.
I'm going to be honest, that looks a little bit scary. Could you break that down for us, non-mathematicians out there?
Sure, no problem. So Cx is the unit cost of producing the x unit. C1 is the cost of the very first unit you produced. X is simply the unit number, so if you're producing the 100th unit, X would be 100. And B, as we said, is that progress ratio.
Right, I remember. So this formula is basically saying that the cost of any given unit depends on the cost of the first unit, the total number of units you've made so far, and this progress ratio, which captures how much you're learning as you go.
Exactly. And it's not just some abstract formula. It's based on real-world observations. Empirical studies have shown that across a wide range of industries, this progress ratio tends to fall within a range of about 0.75 to 0.9, which means that the learning rates typically fall between 10% and 25%.
Okay, so there's some real data to back this up. It's not just theoretical. Now, you mentioned Bruce Henderson and the Boston Consulting Group, BCG, earlier. Weren't they also big proponents of this whole learning curve idea? Didn't they even coin the term experience curve?
Yes, absolutely. Henderson and BCG really popularized this concept in the 1960s, and they saw it as a key driver of competitive advantage. They argued that companies should strive to maximize their learning and experience effects by, among other things, aggressively pursuing market share.
Why market share specifically?
Because the more you produce, the faster you move down that learning curve, the lower your costs become, and the better positioned you are to compete on price. It's a classic positive feedback loop. Increased activity leads to increased learning, which leads to lower costs, which leads to lower prices, which, if all goes well, leads to even greater market share, which fuels further learning and cost reductions. It's a powerful dynamic.
So it's not just about making more, it's about using that increased production volume to learn faster than your competitors and gain a cost advantage that you can then use to further expand your market share.
Right. And BCG went even further, arguing that companies should actively pass those cost savings on to consumers through lower prices.
Why would they do that? Wouldn't it make more sense to just pocket those savings as higher profits?
Well, in the short term, maybe. But BCG argued that in the long run, that would be a mistake. If you keep prices high while your costs are falling, you're basically inviting new competitors to enter the market and try to undercut you. By proactively reducing prices, you make it less attractive for new entrants, and you can potentially even drive some weaker competitors out of the market.
So it's a long-term strategy focused on building a dominant market position through continuous learning and cost reduction. And it all goes back to this basic idea that the more you do something, the better you get at it.
Exactly. It's a powerful concept, and it's not just limited to manufacturing. You see it in services, in software, in healthcare, in pretty much any field where there's a process of learning and improvement over time.
So if we look back at that original example of Ebbinghaus memorizing those nonsense syllables, he was essentially moving down his own personal learning curve, becoming more efficient at that specific task through repeated practice. And Wright's law is essentially applying that same principle to the world of industry and manufacturing.
Right? It's taking that fundamental human experience of learning and scaling it up to the level of organizations and entire industries.
Now, you mentioned earlier that this learning curve isn't always a smooth, continuous downward slope. There can be disruptions, what you called experience curve discontinuities. What are those and what causes them?
Yeah, it's important to remember that this isn't some ironclad law of nature. There are all sorts of things that can disrupt this process of learning and cost reduction. One common cause is technological change. When a new technology comes along that fundamentally changes the way we do things, it can essentially create a brand new learning curve.
Can you give an example?
Sure. Think about the transition from film photography to digital photography. All of the experience and knowledge that camera manufacturers had accumulated in producing film cameras didn't necessarily translate directly to producing digital cameras. They had to learn new manufacturing techniques, develop new supply chains, and figure out how to design for a completely different set of customer needs.
So it's like the game changed, and they had to start a new learning curve from scratch.
Exactly. And it's not just about the technology itself. It's also about the skills and knowledge that people have. When a major technological shift happens, the workforce might need to be retrained, or new talent might need to be brought in.
So it can be a very disruptive process, both for companies and for individual workers.
It can be, but it can also be a huge opportunity for innovation and growth. Sometimes these discontinuities are necessary to shake things up and force us to find better, more efficient ways of doing things.
Now, apart from technological change, are there other things that can cause these disruptions in the learning curve?
Absolutely. Changes in market demand can be a big factor. If the product you're making suddenly falls out of favor, or if customer preferences shift dramatically, you might need to redesign your product or even completely pivot to a new product line. And that can throw off your learning curve because you're essentially starting over with a new set of challenges and learning opportunities.
So it's not just about internal factors like technology and production processes. The external environment, the market, can also play a significant role in shaping the trajectory of this learning curve.
Absolutely. It's always a complex interplay between internal capabilities and external forces. And that's one of the reasons why it's so difficult to predict exactly how these learning curves will unfold. They're not always smooth and predictable.
And I imagine that over the years, there have been some criticisms of this whole concept of the learning curve and the experience curve.
Oh yeah, definitely. Some critics argue that it's too simplistic, that it doesn't take into account all of the complexities of real-world markets and business dynamics. Others point out that it can sometimes lead companies to focus too narrowly on cost reduction at the expense of other important factors like quality, innovation, or customer service.
So it's not a silver bullet. It's not the only thing that matters in business.
Exactly. It's a valuable tool, but it needs to be used wisely and in conjunction with other strategic considerations. It's not a substitute for good management, sound decision-making, and a deep understanding of your market.
Now, we've talked a lot about the applications of this concept in manufacturing and industry, but are there other areas where we see this learning curve effect?
Oh, definitely. You see it in healthcare, for example. As doctors and nurses perform more procedures, they become more proficient, complication rates go down, and patient outcomes improve. You see it in education, where teachers become more effective as they gain experience and refine their teaching techniques. You see it in sports, where athletes develop their skills through practice and repetition.
So it's really a universal principle of learning and improvement applicable to a wide range of human endeavors.
It seems to be. And it's fascinating to think about the implications of this. If we understand how this learning curve works, we can potentially accelerate it, find ways to learn more effectively, and achieve better outcomes faster.
That's a really exciting thought. It's like we can hack the learning process itself.
In a way, yes. And that's one of the reasons why this whole area of research is so interesting. It's not just about understanding how things have worked in the past. It's about using that knowledge to improve the way we do things in the future.
Well, I think that's a great place to leave it for today. This has been a truly fascinating deep dive into Wright's Law and the experience curve. We've explored its historical origins, the underlying mathematical principles, the various factors that drive it, and even some of its limitations and criticisms. But most importantly, I think we've gained a deeper appreciation for this fundamental human experience of learning and how it shapes not just our individual lives, but entire industries and even the course of technological progress.
Absolutely. It's a powerful concept, and it's one that I think everyone should be aware of. Because once you start seeing the world through the lens of the learning curve, you start to see opportunities for improvement everywhere you look.
So for our listeners out there, the next time you see the price of something dropping or the performance of something improving, think about Wright's Law. Think about the cumulative experience that went into making that progress possible, and ask yourself, how can we apply this principle in our own lives, in our own work, to become more efficient, more effective, and ultimately more successful? Thanks for joining us on this deep dive, and keep exploring the fascinating world of science and technology.